Welcome to Super Easy Physics and Mathematics, SEPAM. Watch this video on the review of the IGCSE Physics Alternative to Practical Paper 6. October-November 2022 Examination Variant 1, and learn the secret of getting a star in IGCSE Physics exams.
Welcome to SEPAM. Today we are going to look at the solution to IGCSE Physics Alternative to Practical Variant 1, October-November 2022. In this particular review of this paper, I want to share with you tips that can help you to be able to get the entire 40 marks allocated to this paper. And if you follow this video to the end, you'll be able to master how to answer Cambridge Physics Practical Paper 6 question. And I bet you it will take you up to 50 minutes. We are going to spend less than 50 minutes. This paper takes 1 hour, but you are going to take less than 50 minutes. But in the full, when you go through the entire paper, I know you are going to learn a lot. So I want you to take your time to practically go through the review with me. So let's start. This paper, you are expected to answer all the questions. There are 4 questions in alternative to practical question. And then, like I've said earlier, the total mark is 40 marks. So let's see how you can get the 40 marks. Let's go to first question. Question 1 is the oscillation of pendulum, simple pendulum. Explain how you can measure the center of the pendulum bulb accurately. So how do you measure the center of this bulb? For you to measure the length of the bulb, all you need to do, you hold the bulb close to the meter rule and then position your sight view at this point in order to read it from the meter rule. So position your sight level perpendicular to the center of the bulb. Then you read the value from the meter rule that is held by the side. Now, the student adjusts the length of the pendulum to 50 cm and he measures the time it takes for the pendulum to make 20 oscillations. So what you are expected to calculate the period for 1 mark and then calculate the square of the period. So let's go to the next part. For you to calculate the period of oscillation is the time taken to make 20 oscillations divided by the number of oscillations. So let me show you how to measure the oscillation period. Today we are going to look at how to count the oscillation of a simple pendulum. So let's do that practically. Yes, welcome. Today we're going to look at how to practically measure the oscillation of a pendulum. So the first thing we are going to do, let's measure the length of the pendulum. So we have this slot mass tied to a string. So it's at the point of equilibrium, the pendulum is not moving, and then we have this protractor to measure the angle, the amplitude of the oscillation. So let's measure the length. So from where the support of the pendulum to the middle of the bulb of the slot mass, so the length of this pendulum is 70 cm. So let's take away the ruler So we can take a small oscillation, so very small angle of oscillation. So like this one, this is 911 degree. So the amplitude, so you can release it, then allow it to swing. So for you to have a complete oscillation, a to and fro, that is 1. This is 1, 2, 3. So, but we stay on one side to count. So we count down. So every time it comes to the right, you can count. So when it comes to the right, we count. So let's say, so once it go 3, 2, 1, 2, 3. So let's do a count for 10 oscillations. So once it comes, so are you with me? So let's count. Every time it comes to the left hand side, we count. So let's count down. Then I will use a timer to time 10 oscillations. So let's do 10 oscillations. So how long will it take for the pendulum to make 10 oscillations? So let's go. 3, 2, 1, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how long did it take to make 10 oscillations? That is 16.83 seconds. So that is how you do the counting. So can we count it the second time? So let's reset again and count. So let's go. So this time 3, 2, 1, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one we have 17.03 seconds. So we can use this as the period of oscillation. So the pendulum make 10 oscillation in 17.03 seconds. So let's calculate the period. Period of oscillation, time taken to make 10 oscillation divided by number of oscillation, which is 10. So the formula for period, capital T is equal to the small t divided by n. So we have, so the period of oscillation, that is 17.03 divided by 10. That will give me the period for the oscillation that we've just done practically is 1.703. What it means is that the pendulum will make one complete circle, a complete circle in 0.17, in 1.7 seconds. So because the time is very short, so that is why practically we have to measure multiple repetition of the period. So we decided to multiply repeated period for 10 of them, which we call the 10 oscillation or 10 circles, so that the time can be bigger. Then we reduce the error for human reaction. So let's go to the question paper and continue with it. So like in this question paper, we are expected to calculate the period for 20 oscillation. So complete this table here and then calculate the square of the period. So let's see. So for the first one, when the length of the pendulum is 50 cm, the pendulum took 28.2 seconds. So let's calculate the period. So the period t is equal to small t over n. So that will give me 28 divided by 20. So that will give me 1.41 second. So now to calculate the square of the period, that is t multiplied by t. So that will give us 1.9881. So you have to keep the number of decimal points consistent, 2 decimal points like what you have here on the table. So we have to approximate this, so that will give us 1.199 seconds. Alright, we are expected to plot the graph. Question C, plot the graph of t square against L. So to do that, so t square on the y-axis, then the length of the pendulum L on the horizontal axis. So the first thing you have to do, you draw your line and label the axis, length in cm, half mark, period t square / the unit second square, half mark, that is 1 mark. You must label the axis. Then secondly, distribute the value. The t square range from 1.99 to 3.65. So if you distribute that, so you have 1, 2, 3, 4, 5. Then the length, I started from 50 because we are not required to start from origin 0, 0. So once you are not asked to start from the origin, say you can start from any convenient value. So let's see. So we did that. So we start 50. So let's plot the value. When the length was 50, what was the period? Almost 2, 1.99. Then when the length was 60, we have 4.32. Then when the length was 70, we have 2.82. Then when the length was 80, we have 3.2, 3.1.2. Then when the length was 90, we have 3.65. So the midway between 6 and 7. So draw your line of best fit. So we have our line of best fit. Then, so with this that we have done, you have 4 marks. So you have 1 mark for labeling the axis, 1 mark for the line of best fit, then you have the other 2 marks for the plotting of the points. So your examiner is going to measure it, so don't plot it carelessly. So let's go to the next question to find the gradient. Alright, you are expected to determine the gradient of the graph that you've just plotted. So for us to do that, we're going to find the rise in t square divided by the increase in length. So if we do that, let's find out, we'll pick a point, and the rule of you must indicate the triangle, and when you are indicating the triangle must cover more than half of your line, so 3/4. I tell my students use 3/4. Let the triangle cover 3/4 of your line. If you take a very small triangle, less than half, you won't get the answer. Because what you are doing, you are taking the average. So what is the, so we have this point here, S. So you have the S1 value, you have the S2 value, you have the Y1 value, then you have the Y2 value. So let's look at it. So we find the run, that is the increase in length. So 90 take away 50, that is 40. So let's look at the rise, the increase in this period square. So if you do that, so we can now calculate it. So delta t squared divided by delta L, that will give us the gradient. So we subtract the value, and then you have 0.04125. How do you get the unit? The unit of t squared divided by the unit of length. So approximately is 0.041 second per cm. And then what is the expected value? for you to get the answer, the range of your value must be within this range. So if you have any value between 0.038 to 0.044, you will get the full 3 marks that are allocated to this question. So let's go to the question E. Question E, explain briefly why timing 20 oscillation give a more accurate result for the period than timing 1 oscillation. You know, from the experiment we did, you see that it takes a very short time to make one complete circle. So timing 20 oscillation reduce the error due to the time it takes for students to react to the counting, because the time is very short. So if you are measuring only one oscillation, one complete one circle, the student is bound to make more error than when he's measuring multiple of the circles of the swinging pendulum. So that is one. Then secondly, timing 20 oscillation reduce the human error in the duration of oscillation measured. So these are the basic 2 reasons. So if you have gotten this, so you have collected the first 11 mark out of the 40. So let's go to question 2. Question 2 is on electricity. A student investigates the resistance of a lamp. So this is the symbol of a lamp, a circle with a cross. And then she uses the circuit shown below. So you have a resistant wire connected in series with the lamp. And then we have a jockey connected to an ammeter in series. Then as she slides the jockey from C to E, she is increasing the resistance, because the resistance of a wire increases with length. The longer the length of the resistance of the wire, the greater the resistance of the wire. So if you put the jockey at C, you have a small resistance. As you go to D, you have half of the resistance. When you come to E, you have a bigger resistance. So, and as resistance is happening, what is going to happen to the current? The current will start reducing as the resistance. So as the student moves the jockey from C to E, the current that will be measured will be what? Reducing. Okay, and how do you get the resistance of this lamp? From Ohm's law, V is equal to IR. So if you want to measure the PD across the lamp, so the PD also will be dropping in a similar proportion as the current is dropping. As you increase the resistance, the current will be dropping, so the PD across this resistor will also be dropping. So let's go into the question. It said draw a voltmeter connected to measure the PD across the lamp. So put a voltmeter. Voltmeters are always connected in parallel to the resistance, to the resistor that they want to measure the PD. So we put the voltmeter. The symbol for a voltmeter is a circle with V inside. So you connect it in parallel. So with this, you have your 1 mark. So a student move the slide. So he measures the PD across the lamp and then the current flowing. So let's measure the PD across the lamp. So this is 2. So, and if you look at it, the gap between 2 and 3 is 5 equal division. So each one will be, so this 2.2, 2.4. So V1 is 2.4 volts. Assuming the unit is not written there, you are expected to write the unit to get the full mark. But you are already given the unit, so just write the value. So let's measure the current. So if you look at the current, you see the scale for the ammeter is different from the scale of the voltmeter. Now if you look at the ammeter, you have, this is 0.2, okay, then 3, then 4. Very good. So it's a bit this. All right, so let's just go. So if you look at it, this is 2. So you have 3, 0.3, so 0.32. So 0.32 ampere. So let's go to question BII. Calculate the resistance R1 using the equation R1 is equal to V1 over I1. So just substitute the value you've just measured in BI. So that will give me 2.4 divided by 0.32 ampere. So what is the unit of resistance? So in this question, you see the unit is not given. So you are expected to write the unit. So divide that. That will give 7.5 ohms. Or another way for you to hack this question, if you don't know ohm as a unit, all you need to do, write V/A. So it will be given to you. So that's another way. Okay, she placed a slide contact S on the resistor wire as close as possible to D, to the point as the midpoint of the resistance. She measured the PD V2 across the lamp. So V2 is now 1.4. So you see, I told you earlier on, as the resistance increases, the PD reduces because current is reducing. So you look at it, the PD have reduced from 2.4, it reduced to 1.4. And then the current also measured 0.24. Now calculate the resistance R2 of the lamp using the formula V2 over I2. So substitute. We have 1.4 divided by 0.24. That will give us 5.833 ohm. So you see the resistance of the lamp is reducing. So you are expected to put your answer to a suitable number of significant figure. So you can use 2 significant figure or 3 significant figure. But normally our ammeter can measure up to 2 decimal points like this based on this value given to you. So just look at the value given to you in the question and write your answer according to the same number of decimal points. So you get it. So now I decide to use 1 decimal point here. So you can use, this is 2 significant figure. But if I have written the answer to 5.83, so I'm say 3 significant figure. If you write this, you are wrong because of this question. Use the number of significant figure. So let's go to the next question. She placed the slide contact S on the resistance wire as close as possible to E. So it's having the full, she's taking the resistance of the entire resistance wire. She measured the V3 across the lamp 0.9 and then the current flowing was 0.18 ampere. Calculate the resistance, measure the equation using the equation V3 over I3. So substitute. That will give us 5.0 ohms. So these are just substitution questions. So complete the following sentence referring to your practical experience and the results. So this is a question that has to do with. So let's see. As the length of resistance wire included in the circuit is increased, the brightness of the lamp, what is going to happen to the brightness? Because since the current is reducing, the brightness is also going to reduce. So the brightness of the lamp reduces because the current reduced from I1 when we started was 0.32 ampere, but eventually it was reducing to 0.18 ampere. So you quote the value. It's like a question that has to do with justification. You say your practical experience and the results. So as the length of the resistance wire included in the circuit is increased, the resistance of the lamp also what was the value? Reduced, because the resistance recorded reduced from R1 equal to 7.5 ohm to R3 5.0 ohm. So the value reduced from this to this. So you just put it there. So question F. A variable resistor can be used in this type of experiment in place of the resistance wire. Draw the circuit to show a variable resistor in place of the resistance wire. Include ammeter and the voltmeter in your diagram. So all you need to do, replace that resistance wire with a variable resistor. So this is the symbol of a variable, a rectangle with an arrow across it. There is the symbol of a variable resistor. Put in place of the wire, you retain your ammeter, retain your voltmeter. So what they are saying, just replace this with this variable. So you get that, which is your 3 mark. So this 3 mark will be awarded for your ammeter symbol, your voltmeter 1 mark, then the correct symbol of your variable resistor, then getting your line, the wire correctly. That is a 3 mark. 1 mark, 1 mark, 1 mark. Question 3 has to do with a student investigate the effect of starting temperature on the cooling rate of water. So you need a thermometer and a beaker. So you put the water in the beaker, put the thermometer, pour the hot water, and then record the start temperature. Then you time how long it takes for the temperature of the water to drop, and you measure the time at various intervals. Take note of this every 30 seconds. So complete the time. So let's complete the time for the table. So take note of this every 30 seconds. So let's go. Now, every 30 seconds, take note. So if he started with 0, so the next time he recorded, he started with the temperature of 88 degrees Celsius. Then after 30 seconds, so 30 seconds, he measured 82 degrees. Temperature dropped by 6 degrees. Then another 30 seconds, that is 60 seconds, temperature drop again. This time from 82 to 78. So this time 4. So the first time 6, second time 4, then drop again. So 30, 30, 30, you just keep on the value, because every 30 seconds. So that's how you generate this. So 30, 60, 90, 120, 150, 180. So if the unit was not given, you would have supplied the unit, but already the table, the heading are already, the unit has been written. So let's go. Calculate the decrease in temperature between T0 and T180. So decrease in temperature between T0, so you have this, the red, the beginning and the end. So what is the decrease in temperature? So that will give me 88 take away 65. So that will give me 21 degrees Celsius. Calculate the average cooling rate. So delta theta divided by, so drop in temperature divided by the time taken for the temperature to drop. You say use the 180 degree. So you have 21 divided by 180 degree. So what will be the unit? So I'll give me 0.117 degrees Celsius per second. So every second, this is the cooling rate. Now the student empties the beaker and he pours warm water into the beaker. This time, he records the temperature of the water. Now it started with 74. And this time, the temperature is not as hot. The water is not as hot as the initial first one he did. So he time it again every 30 seconds. So the first 30 seconds, 74, it dropped to 30, 71, 74. So it dropped in 3 seconds. Then between 30 and 60, it dropped with 1 second. So 70, it came to 71. So you see that the cooling rate of this one is lower than when the water was hotter. The student emptied the beaker and does that. So let's see what, using the table, calculate the decrease in temperature between T equals to 0, the time 0, and 90 seconds. So from year to year. So we have that 74 take away 68. That will give me 6 degrees Celsius. Then calculate the cooling rate. So 6 degrees divided by 90 seconds. That will give me 0.067 degrees Celsius per second. So you have your 1 mark. Okay. A student suggests that the rate of cooling of water depends on the initial temperature of the water. Write a conclusion about the effect of initial temperature of water on the rate of cooling of water. Based on the result, justify your conclusion by reference to value from your result. So this is a question that has to do with justification. So any answer you are going to give as your conclusion, you should be able to make reference to it in the practical, in your data given to you in this particular practical. That is a question that has to do with justification. Prove it. Your answer, back up your answer with the data given to you. So that's how you answer justification question. So what is the higher the initial temperature of the hot water, the higher the rate of cooling of the water in the beaker. So that is this in this experiment. That is the trend of the data. Then justification. When the initial temperature was 84 degrees Celsius, the rate of cooling was 0.156 degrees per second. Now, what I decide to do here is I decide to calculate the rate of cooling for the same amount of time, that is for 90 seconds. You see in this question, the examiner decided to use 180 seconds and 90 seconds. So they are trying to confuse you so that you cannot take note of the timing. But one thing is that if you are comparing experimental data, you should use the same range, use the same standard value. So I'm using the same duration of time, 90 seconds. So the rate of cooling for the hot water 84 degrees is 0.156 per second, while for the warm water that started with 74 degrees, rate of cooling is 0.06. So that is a reference here. So you see that the rate of cooling here is lower, while the rate of cooling for hot water, the hotter the water, the higher the rate of cooling. So the temperature drops faster. State 2 requirements when reading the volume of water in a measuring cylinder in order to obtain an accurate answer. So what do? First of all, position your sight level perpendicular to the scale calibration on the measuring cylinder. Then the second one is read the volume from the lower meniscus. The volume, read it from the lower meniscus in the measuring cylinder. So if you have your measuring cylinder, so if you have your cylinder, so you have this is a measuring cylinder. So you read it from the lower meniscus. So you read your volume from here. So you read it from this value. You don't read it from this point. So you read the value here. So the lower meniscus. So that's what you read. Suggest 2 possible values that the student should keep constant in this experiment. The amount of water, 200, you already be given, you keep it constant. The volume of water, keep it constant. The room temperature, keep it constant throughout the experiment. So if you do that, you have your 11 mark, that is 22 mark. So the time interval of measuring the temperature drop, you keep it constant. So like in this experiment, the student was measuring the time, the drop in temperature every 30 seconds. So take note of that. So question 4. Yeah, this is a technical question that has to do with planning of experiments. Yeah, I like this type of question. So let's go into it. A student investigates the horizontal distance traveled by a metal ball after it rolled off the end of a plastic. So the ball rolls from here, then it drops here. So you are going to measure the distance from here to here, from the leg of the bench to this point. So you measure this distance D. Okay. Now, the ball rolled down the plastic track. The left-hand side of the track is fixed, so this side is fixed. While this side is flexible, you can adjust the angle. The student measure the horizontal distance that the ball travel from the right-hand side. So travel from the right-hand side. Plan an experiment to investigate how the horizontal distance D traveled by the metal ball depend on the angle that the right hand end of the track make with the table. So this angle here. So what is the angle that it make here? So you're going to vary this angle. So let's go into the planning. Now these are the steps you must follow. The following apparatus are given to you: track with stand, the balls and the clamp, selection of metal balls. Other apparatus normally available in the school laboratory can be used. So you see now there are some important, for example, what will you use to measure the distance? It's not given to you. So you need a measuring tape or the ruler to measure that. And then also I think a protractor, what we use to measure the angle. What we use to measure the angle. So you need a protractor too. So another material that you need a protractor, you need a measuring tape. Then in your plan you should, so you follow this, let this guide you, list any additional material apparatus required. I just mentioned a protractor, your measuring tape for measuring the distance, and the protractor to measure the angle. Explain briefly how you will do the experiment, include the measurement you will take. State the key variable to keep constant. Well, if you want to do this, I'll keep the ball constant, the size of the ball. I will keep where I'm dropping the ball constant. Okay. So draw a suitable table with column heading to show how you will display your reading. You are not required to enter any reading in the table. Okay. Explain how you will use the result to reach a conclusion. So let's go. So we have this. This is the setup. So you have the plastic, you have the clamp, so the setup is there. But what I'm going to add now, I need the sand tray so that when the ball drop, I can get the position where it strike the sand tray here. Then I will measure the distance from the leg of the bench. So what are the extra material I needed? Measuring tape, I need the sand tray. So this is the sand tray here, blue. So let's see. So the first thing, what is the procedure? The procedure here, I will set an angle, set this angle here to 20 degrees using a protractor. Then next, I will drop the ball close to the clamp. So I will keep on dropping from the same position. Then after dropping it, I will allow it to roll. Then it drop. So you see the ball rolls from here. So I allow it to roll. And then it flip and drop here. So I measure the distance. So I can repeat it for every angle. I repeat it like 2 times. So I find the average of the distance. So when the angle is 20, I repeat the distance. The first distance I measure D1. Then second distance D2, I will find the average. Then next thing, I increase the angle to 30 degrees. I will repeat the distance again, find the average. increase it to 40 degrees, measure the distance, D1, the first one, measure a second time, find the average. Increase it to 50 degrees, increase the angle to 50 degrees, measure the distance. So that is the setup. So I select a fixed ball and release it by dropping it on the track just near the clamp. Drop it here. I measure the distance D1 where it strikes the sand tray position on the floor to the right of the track. The distance is measured from the length of the bench. So I did that, so you state that. Then I record the angle theta equals to 20 degrees and the distance D traveled by the ball. Then the next thing, I repeat step 3 again with the same size of ball with the same angle for 20 to get D2. I record the distance D2 traveled by the ball and calculate the average distance. So how do I calculate the average distance? D1 plus D2 divided by the number of time. So that will give me the average distance D. So I will tabulate. So I set the angle at 30, repeat the process again. So repeat step 1 to 5 for each value of angle, 30, 40, and 50 degrees. And then table of value. So we have this, the angle theta measured in degree, then distance measured in cm, D2 measured in, this is the first reading, second attempt, then the average. So I've shown you that. So when you get your value, you can record that. Now, what will you notice? When the angle is smaller, the object is going to travel faster. But as the angle is getting, the distance will be reducing. So, what are the variables kept constant? The size of the ball, the point from which the ball is released on the track. So, I keep those things constant. And analysis of data. I plot the graph of angle on the y-axis and distance travel on the x-axis. Then when I finish plotting, I can find the gradient. So I can now know the pattern. So conclusion, so as the angle increases, the distance traveled by the ball reduces. So with this, you have your 7 mark and you have all the mark. Very good. We've come to the end of Alternative to Practical Paper 6, Variant 1, October-November 2022 series. So I want you to subscribe to Super Easy Physics and Mathematics. I want you to share this video with your friends so that they can have opportunity to learn this thing. I know physics is very easy, and as you stay tuned with this channel, I know your grade. I'm expecting all the subscribers, all the students that subscribe to this channel to come with A star. I've done that. Most of the students that I've taught and prepared for this exam in my school will come out with A star. So I want you to enjoy this experience. I'm here to share my experience with you of preparing students for this examination. So I'm wishing you good luck. Just keep reading. Well, the rule of the game is practice. Physics is very easy. Physics is not difficult. Tell somebody that Mr. Matthew said that physics is the easiest subject. So stay tuned. Thank you.
Subscribe and we will help you to easily upgrade your performance to an A+.
SEPAM is the solution to better grades.